Properties is electronegativity, which is denoted by this particular symbol. This is known as chi. This is known as chi, K-I-I. It is spelled as chi. It is written as. So when I have an element, let us say A, so it is spelled as chi A in this way. So electronegativity, first of all, is denoted by this. So what is electronegativity? The tendency of an atom to attract the shared pair of electrons towards itself to form a covalent bond. We can say that. So what is electronegativity? It is a tendency of an atom to attract the shared pair of electrons towards itself to form a covalent bond. Similarly, so when you move from left to right across a period, so same thing, let us say second, third, any period we can say. Let us say I am taking third period. This is your third period I am taking. Sodium, magnesium, aluminium, silicon, phosphorus, sulfur. We can still move forward. Chlorine, argon. Now, which element have a tendency to gain electrons? What I said you, again I repeat the definition. It's a tendency of an atom to attract a shared pair of electrons towards. Sharing is going to take place. So, sharing is going to take place in which particular cases? This particular cases, the sharing is going to take place. Because in this case, again I repeat, it is having a tendency to lose electrons. It is having a tendency to lose. So lose means going to form cation. Now it is having tendency to gain and share. Rather, sharing of electrons takes place here. Okay. So as a sharing is going to take place here, so these elements have got the maximum electronegativity. Hence, when you move from left to right across the period, same thing I repeat it. The nuclear charge increases, electronegativity increases. When you move left to right across the period, that is nuclear charge increases and electronegativity also increases because it is affected by the nuclear charge. Similarly, when you come down the group, same thing, atomic size is increasing, electronegativity is decreasing. When you coming down the group, electronegativity is decreasing. Same thing, number of shells increases, so electronegativity decreases. We can say that. So again, same thing, this particular element, inert gas, has zero electronegativity because it does not have any tendency to attract the shared pair of electrons towards itself. Why? Because its outermost shell is fully filled. So it does not have any tendency to attract the shared pair of electrons. So in that particular case, what we can say is that is in the second period we are having fluorine. Fluorine is having the maximum electronegativity, and in this case we are having that is cesium. That is cesium is having the least electronegativity. Alright. The least electronegativity in case of the group 1 element, that is metal, is cesium, and maximum electronegativity in the what you can say group 17 element is your fluorine, because across the period increases. So this is having the maximum. Its electronegativity value is 4, and it does not have any unit because what I said you, it is a tendency. It does not have any unit. Remember it. And here the maximum is your cesium. Why not francium? Because francium is radioactive unit. So we can say that for that particular purpose, cesium is having the maximum electronegativity. Okay. So down the group decreases, across the period it increases. This is about your electronegativity. So we have finished all the 4 periodic properties. That is your ionization energy, what you can say, electron gain enthalpy, electronegativity, metallic and non-metallic character also same thing. Metallic character, it decreases across the period, and down the group it increases. So the highest metallic is your francium, because after that we are having French, we can say. And across the period, as I said, your metallic character is decreasing across the period. Alright, so hence it changes from metallic to non-metallic. So hence I told you in the previous classes, if you remember it, that is these oxides are metallic oxide or basic oxide. The hydroxides are also basic. The hydrides are also basic. But when you move from left to right, it changes from basic to amphoteric to acidic, we can say that, because it changes from metals to non-metals. Similarly, if you see the density, if you also see the density what you find is that it increases from left to right across the period. Why it increases the density? Because atomic size is decreasing, density is equal to mass by volume. So atomic size is decreasing, density is equal to mass by volume. So density is inversely proportional to volume, you can say that. So hence, as you can see, density is inversely proportional to volume. So volume is decreasing, so density is increasing. So across the period, density increases. Across the period, melting point also increases. Melting point increases. Density increases. Across the period. It is across the period. This one is across the period. We can say that. when you move from left to right. Similarly, when you come down the group, what you can say is that the density is also increasing. Now, quite funny this one is density is increasing. You might be thinking density is inversely proportional to volume. So here the volume is increasing because the number of shells is increasing. No, at the same time, what you can find is that volume increases, no doubt about it. Atomic size is increasing, but at the same time, the mass also increases because when the atomic size is increasing, number of electrons is increasing. So the mass dominates over the volume, due to which, as I said, your density is directly proportional to mass and inversely proportional to volume. So when you are coming down the group, definitely the volume increases, but the mass dominates over the volume because the number of electrons also increases. Number of electron, proton, everything is increasing. Alright, as well as the neutron. So hence, due to which the mass increases and the mass dominates over the volume. Due to which, what you find is that when you come down the group, the density increases. It increases when you come down the group. Density is increasing when you are coming down the group. You can say that. Similarly, that is here it is opposite. Here I said melting point increases, but when you come down the group, the melting point decreases. Boiling point decreases. Why? Because the atomic size increases. As the atomic size increases means the electrons are far apart from each other. It is becoming easier for you to break. Alright, so hence less energy is required. For that purpose, melting and boiling point is decreasing. So this is about your periodic properties which we studied. Rest all the things, I will give you a note, I will send you a note, I will write a summary and I will send you a note that I will send you a pic, you can check it.